Hi everyone. Welcome to the Science Info channel. Today we are discussing Jupiter's Great Red Spot, which is a ruthless cannibal that devours smaller storms. Before we get started, make sure to like and share this video, smash the subscribe button and click the notification bell. What's the secret to a long life? For the Great Red Spot, a massive storm that has churned on Jupiter's surface for at least 150 years, the answer may be cannibalism. The Great Red Spot is about twice as wide as Earth. But over time, it's been gradually shrinking, and the storm is currently half the size it was at the end of the 19th century. So when a string of smaller atmospheric storms collided with the Great Red Spot in recent years and caused bits of the bigger storm to flake off, scientists feared that the long-lived and iconic Great Red Spot might be torn to pieces. Instead, the Great Red Spot slurped up its smaller cyclone siblings and was none the worse for wear. And much like the energy drinks consumed by human athletes, small storms may provide a much-needed boost to the Great Red Spot, ensuring that it keeps spinning for years to come. Regular observation of the Great Red Spot began in 1850. Some claim the honor belongs to Italian astronomer Giovanni Cassini, who described the storm in 1665, while others insist that the English scientist Robert Hooke did so 1 year earlier. The storm lies near Jupiter's equator in the southern hemisphere, and it rotates counterclockwise. Much like the hurricanes that form on Earth, the eye of the storm is relatively quiet. But winds that are farther from the center can reach speeds up to 425 miles per hour, 680 kilometers per hour, NASA says. No one knows what lends the Great Red Spot its distinctive red color, or what spawned the enormous storm centuries ago. However, it may have lived so long because Jupiter lacks a solid surface under 44 miles of cloud layers. Land formations on Earth slow and dispel powerful hurricanes, so it's possible that the Great Red Spot rages on because there's no landmass below to stop it. But whatever fueled the storm's birth and growth may be slowly fading away. In 1879, the GRS measured approximately 24,850 miles wide. Since then, it shrank to about 9,320 miles. To learn more about the Great Red Spot and other Jupiter mysteries, NASA launched the Juno mission in 2011. With its arrival at Jupiter on July 4, 2016, Juno became an orbiting eye in the sky for peering through the gas giant's dense cloud cover and capturing close-up images of the Great Red Spot and other phenomena, such as a hypnotizing vortex cluster at Jupiter's North Pole. What about a threat from the east? Between 2018 and 2020, when the Great Red Spot was smaller than it had been in 150 years of observations, it was bombarded from the east by dozens of anticyclones, storms that have high-pressure centers and spin counterclockwise, that ripped large red swaths from the spot's main body. Small vortices had slammed into the Great Red Spot before, but never so many in such a short time span, scientists wrote in a new study. Its structure and even its survival appeared to be threatened, researchers reported March 17 in the Journal of Geophysical Research, Planets. For their study, they investigated the impact of these smaller storms on the Great Red Spot. They measured and mapped cloud features and images of the Great Red Spot, captured by the Juno spacecraft's JunoCam, by the Hubble Space Telescope, by the Calar Alto Observatory in Almería, Spain, and by amateur astronomers using ground telescopes. Though the Great Red Spot dwarfs these anticyclones, they were still quite large, measuring about 10 times the size of hurricanes on Earth. As they drew closer to the Great Red Spot, they peeled away strips from the central part of the storm, creating red streamers. The collisions also distorted the big storm's overall shape. All this significantly disrupted the red oval area of the Great Red Spot, and was even suspected of putting its long life at risk. However, the damage was superficial. The Great Red Spot extends to a depth of about 125 miles. Changes in structures and reflectivity in the Great Red Spot and the flakes of red in simulations of the collisions revealed that the rip streamers were just a few kilometers deep. By October 2019, the visible red oval had almost recovered to its previous size. What's more, the velocity of the giant red spot's internal rotation increased after its ingestion of the smaller storms. Colliding with the anticyclones didn't drain the Great Red Spot's strength or nudge it closer to destruction. Rather, it demonstrated that a cannibal diet can increase the Great Red Spot rotation speed, and perhaps over a longer period, maintain it in a steady state. Thanks for watching.